Hi, my name is Furqan. I am an applications engineer in Maxim Integrated. Today I will be discussing about how Maxim's no-opto isolated power supply solutions enable customer to achieve more compact, well-regulated and efficient power supply solutions. This is the first video of this series. Isolated power supplies are used to achieve voltage level shifting, ground isolation, multiple outputs possibilities and for safety reasons. Output voltage feedback is required for proper voltage regulation. In conventional isolated power supplies, it is achieved by using a secondary side error amplifier, an optocoupler and associated discrete supporting components. These feedback components not only make the power supply design more complex, but also increase the bill of material cost and overall size of the solution. Current transfer ratio capability of the optocouplers age with time and their varying values can deteriorate the overall performance. Maxim's no-opto technology eliminates optocoupler and associated discrete feedback components and regulates the output power supply based on the output voltage information available at the primary side of the transformer. This ensures a more compact, smart and efficient power supply solution. Maxim's first no-opto power supply configuration is called the isobuck. An isobuck is a buck converter whose inductor is replaced by a transformer. The transformer acts as a coupled inductor where it stores energy during the on time and transfers it to the secondary winding during the off time of the switching period. The voltage at the primary capacitor C' is well regulated by a primary side feedback loop. The isolated output voltage across the capacitor C out is the scaled version of the well-regulated primary side voltage across the capacitor C'. The scaling is contributed by the transformer's turns ratio, the diode foul voltage drop and drop across the associated parasitics. Isobuck can provide one non-isolated and multiple isolated outputs. Here I have MAX17681 EV Kit running at 200 kHz. This design can take wide input voltage from 17 volt to 32 volt and generates dual output voltages of plus 15 and minus 15 volts respectively. The two outputs also have post regulators to develop plus minus 12 volt if required. Both the outputs can supply up to 100 milliamps to the load. I am probing plus 15 volt output and you can see the output voltage ripple. The second channel I am probing is the drain source voltage of the primary side MOSFET whose switching frequency is 200 kHz. Now I am introducing a 50% load step at the output where load current is increased from 50 milliamps to 100 milliamps at a frequency of 100 Hz. Here you can see a damped, well-stable output voltage response where voltage is being regulated by regulating the voltage at the primary side capacitor. Isobuck can provide plus minus 10% output voltage regulation and it is ideal for high efficiency space constrained application where usually a post regulator is used to further regulate the output voltage. The main advantage of isobuck is this that it has simple control with one magnetic element and it can provide multiple output voltages with and without isolation. For more information about isobuck and its associated design resources, please see the link below, the address of which is also given in the description of this video.